morning, I'm Zersha.
And I'm Zian.
This will be our project, Magnetic Levitation. And this will be our train. And our track. Yeah. We will be explaining in this video how magnetic levitation actually works.
Hi, my name is Zion. Today I'm going to discuss about what is magnetic levitation, its advantages and disadvantages. Firstly, the conventional transportation nowadays is causing a lot of pollution by the burning of fossil fuels and leaving a huge carbon footprint. Nowadays, long distance travel are often exclusive to air travel. However, we have found a greener way to go, which is magnetic levitation. Magnetic levitation was discovered almost a century ago, and the advancement of technology has allowed us to make dream a reality. Magnetic levitation, or MagLev, is a train system that relies on magnetic propulsion, which can be categorized into first, EMS, electromagnetic suspension, and also EDS, electric dynamic suspension. Now, for the advantages and the disadvantages. The advantages is, firstly, there is no physical contact, therefore the only friction force is air friction, which is minimal. Then there is the absence of wheels, therefore there is no rolling resistance, and also it creates a quiet environment which enables a comfortable journey throughout the ride. Thirdly, magnetic levitation is very environmental friendly because it has no engine and does not have combustion of fossil fuels. Therefore, it has no pollution. Then, weather doesn't hinder performance because it is enclosed in the track. Lastly, magnetic levitation train is faster than a conventional train, of achieving more than 500 km per hour compared to the conventional train of maximum 370 km per hour. Then, the disadvantages of magnetic levitation trains. Firstly, the cost of magnetic levitation train is very high on the initial setup because the track of the magnetic levitation has to be set up from scratch, which is very costly. Then, as the magnetic levitation requires a very strong magnetic field to levitate the train, which also requires a lot of energy. Okay, now I'm going to show you how magnetic levitation train reaches its top speed of 500 km per hour by using this formula. We're going to take E, constant of 10 million joules, and M, constant of 1000 kilograms. there you go.
Hi, my name is Leshang. I'm going to explain about the basic of magnetic levitation, which is magnetic propulsion. This is our train, you can see closer, and it is fixed with 4 ceramic magnets. This is where we are track, and we'll explain how magnetic propulsion works. Okay, first, it levitates. It doesn't touch the magnet at all, okay, on the track. This allows the friction to be minimal, as Sion said earlier, and with this track, it can also move forward with a slight push. Imagine if the entire track is filled with magnets. It can push the train all the way without any friction. Why is this good? It's good, as like Sion said, it can reach a high speed of 500 kilometers per hour. Imagine if a train like this can travel at 500 kilometers per hour. That's even faster than your Bugatti Veyron can travel. You can save a lot of time. For example, it may take 1 hour or slightly more than 1 hour to go from Kuala Lumpur to Singapore, which is a very short time. Hi, now I'm going to talk about both the magnetic levitation systems. They actually use electromagnets. Unlike these ceramic magnets, their magnetic strength can be adjusted by changing the electricity. Okay, first, the EMS or electromagnetic suspension. It can be created by generating a levitation system between the vehicle and the track. EMS was made practical by advancement in electronic control of the system, thus allowing a gap between the track and the train, creating a gap which reduces friction. This system can also create a constant magnetic field by measuring the amount of payload, the payload weight, the dynamic load, and the guideway irregularities, which are human weight, luggages, and the weight of the train itself. It can be compensated by generating enough electricity to make the electromagnetic strong enough to withstand the amount of weight it's pushing down. This allows the train itself to levitate all the way, and therefore creating an electromagnetic suspension or EMS. Okay, now we'll talk about the electrodynamic suspension. Unlike the first one, the electromagnetic suspension, the train of the electrodynamic suspension uses fixed magnets. Okay, these magnets are fixed. They are not normal. They are not electromagnets. They are just normal magnets, usually neodymium magnets. Okay, so what it does is the track will be induced with current. Okay, this allows the current to push the train, the electromagnet to push the train forward. The track has induced current. The train has fixed magnets. Okay, so electromagnet on the track, a fixed magnet on the train. Okay, the bad thing about the EDS train, electrodynamic train, is that it has to have wheels. It has to start somewhere. Okay, when there's no electricity, the wheels will touch the ground. Okay, when the current is induced in the track, the train will be pushed by the current slowly until about 40 kilometers per hour, and you move exactly like the electromagnetic suspension. The better side of it is that it is closer to the track, much closer to the track, so it's more stable than the electromagnetic suspension. This means instead of moving around the track, in the train, you'll be much more stable. It will be a smoother, more comfortable ride. Okay. How the fixed magnet works is actually through cryogenics. They cool the magnets down to a certain extent so that it traps the magnetic field. And also they use superconducting magnet technology. Okay, so EDS has a fixed magnet and induced current trap.